Okay, folks, for this screencast, we're gonna revisit meshing, except we're gonna go, rather than making like cubes and spheres and stuff, we're just gonna plot like two-dimensional surfaces. So it's really easy to plot a three-dimensional function. Well, let's just start with 2D. So let's say you have, t is 0, 0.1, 2 times pi, like this. You have x is cosine of t, you have y is sine of t, and then you do, let's drop a figure down, plot x comma y. There's a circle. Everything's all fine and dandy. Let's say you have z in here, which is, let's make this a sine of 2t. Let's make this interesting, and then we'll drop a figure down and we'll do plot x comma y comma z. And so what we should get, didn't like it. Oh, okay, because I used plot. I need to use plot 3. And so basically what we have is, if we look at it from a top-down view, oh sorry, I hit this rotation button. If I look at it from a top-down view, I've got a circle, and then if I look at it from a side view, my z-coordinate is essentially a sine wave. So I can make this like really gnarly. I can make this go to 4 pi, and now, I don't have enough data points. There we go. That looks freaking sweet. It's like a accordion kind of thing. So again, if I look at it from a top-down view, it's a circle, but from a side view, I've got this craziness. Now, if you notice, this is a line, right? This function is like, z equals sine of 20 times t, which is just a function of t. But what if it was a function of x? So what if I had, what this is sort of a parametric function here. But what if I had a z equals f of x comma y, something like that? So what would that look like? So say x goes from minus 10 to 10, and y goes from minus 10 to 10, and z is, let's do something simple for now. Let's just do x squared and y squared. And so if I plot x comma y, plot 3, and run that, again I'm going to drop another figure down, I just get this, right? I just get one line. That's a quadratic, but if you notice, if I look at it from a top-down view, it's only defined along this axis, but I want a surface. I want a 2D surface. So how do I do that? Well, what you do is you use this function called Meshgrid. So you say Meshgrid x comma y. And I'm going to run this without actually doing anything. So if I type in x, that's a lot of data points. Let me go back to the code. What's going on here? What's happening? Okay. So I'm going to just go by 2s. So it's going to be very coarse. And so I'm going to type in x. There's my data in x. There's my data in y. I'm going to type in xx. xx is now a matrix. If I type in whose, x is a 1 by 11, xx is an 11 by 11. If I type in yy, it's essentially the transpose of xx. So like if I type in xx transpose, that's the same thing as yy. Yy transpose is the same thing as xx. But that's only because I defined my limits. If I do this as 100 to 100, that's not going to break the code. It's going to break z, sure. So I'm just going to delete that. But it's not going to break Meshgrid. Meshgrid has no problem with it. If I look at x, x is a 1 by 101, y is a 1 by 11, xx is an 11 by 101. So if I type in xx, here's all of the data for it. It's got 11 rows, 101 columns, and if I type in yy, it's the same size, but it's, again, flopped. But it's not only flopped, notice that x goes from negative 100 to 100, and yy goes from negative 10 to 10. And so it's a little bit different. So I'm going to go back to 10 and 10 here, and so the reason why you do this is because now you can say zz is xx dot hat squared plus yy dot hat squared, and now I can do mesh xx yy zz, and if I hit F5, there's a nice, sweet, awesome surface there. I can increase my mesh grid here, and now I've got a way finer mesh like this, which is pretty neat. If you notice, it's not a perfect bowl because the limits, the bounds are clipped on this side and this side. If you want it to be spherical, where it actually kind of looks like a real bowl, you have to use polar coordinates to get that to work. I'm going to pause it and see if I can get that, figure that out, and then I'll unpause. But basically, this is what you want to do if you want to make a mesh grid. Now, if I go from minus 100 to 100 and hit F5 here, now you get the situation where, you know, X went from minus 100 to 100, and Y only went from minus 10 to 10. And so it kind of bloated the thing here. If I do an axis equal, we should be able to see this better. Yeah, there you go. So now you can really see the fact that, you know, I'm trying to get this. My computer's dying. There you go. So X went from minus 10 to 10, but Y only really went from minus 10 to 10. So axis equal tries to equalize this entire thing. So there you have it. That's the pretty simple thing there to get this code to work. I'm going to try to get the polar coordinates to work at this point, so I'm going to pause it and then unpause. You can essentially turn off the video right now, or you can just fast forward to the end. But post some comments below if you have questions about meshing, and happy coding. Okay, folks, I figured it out. I'm going to make a separate video for this because this is way more complicated than I thought. Here it is if you want to look at it. If it makes sense to you, great. If not, I'll post a link over here, or I'll post a link in the comments or in the description, and show you how to do this revolve plot. Here it is, so you see what's happening. It's actually making like a really nice bowl here, which is pretty neat. Again, I'll post another video on that. Okay.